Hello, welcome to the revision sheet for the Year 11 Intermediate Maths Paper 2 November 2018 paper. Okay, so this is just a revision sheet going over questions similar to those in the past paper. Okay, so let's have a look at the questions now. So first up, we got calculator skills. Okay, so we are asked to work out 6.73 squared, take away the square root of pi, and we need to give our answer correct to 3 significant figures. So this is a calculator paper, so let's get a calculator up. And for these ones, you just type in what you see in the question. So you do 6.7 to the power of 3, and that's usually this x. There's usually a little square above it, and that tells you that you put in x to the power of something. You do x to the power of 3, and then if you press, so we got that, and then we're going to take away, and then square root, and then pi is, you have to press shift and the pi button on the calculator, and you press equals, and we get 298.99.05461. Okay, but we only want this to 3 significant figures. Okay, so we only want the first 3 non-zero numbers. Those will be 2, 9, 8. But we need to check if the last number rounds up. The number after the 8 is a 9. So that means we will round this up to 299, okay? So working out this question, the answer will be 299 to 3 significant figures from 298.99, etc. Okay? And the next one is calculate 74.1% of £552. Round your answer to a sensible degree of accuracy. Okay, so we need to find 74.1% of something. Now we're going to use a multiplier. 74.1%. If we were to write that as a decimal, it would be 0.741. So all we're going to type in our calculators is 0.741 multiplied by 552. See what this is equal to, get our calculator back up. Just type it in, 0.741 times 552. Now our answer is 409.032. Now, because this question tells us to round our answer to a sensible degree of accuracy, money is measured in pounds and pence. If you want to think of the pence, we get 552 pounds and 12 pence. That's the same as 2 decimal places. So 409.032 to 2 decimal places will be 409 pounds and 3 pence. So 409.03. And then, so the answer to this question is simply going to be 409 pounds and 3 pence. Okay, so answer equals 409 pounds and 3 pence. Okay, so we're converting percentages into decimals and then multiplying our number by the decimal, and that'll give you the answer. And we've rounded it to 2 decimal places because we're dealing with money. Okay, are all pentagons similar? So a similar shape is a shape that has the same angles as another shape that is bigger or smaller than it. So for example, this right angle is similar to this right angle because even though they're different sizes, the angles are the same. But these 2 triangles are not similar because they've got different angles. We can see this is an isosceles, a very badly drawn isosceles, and this is a right angle triangle. These are not similar, okay? Therefore, if we're being asked if all pentagons are similar, so we can start off with a regular pentagon here. If all pentagons were similar, there should be no way to draw a pentagon other than this one here. This is just a regular pentagon. But as we all can probably realize, we can draw lots of different styles of pentagons. We can draw pentagons that look like houses. We can draw slightly weirder ones like this. Okay, so we can draw lots of different pentagons. Okay, and these are all not similar. So the answer to this is a big fat no. Okay, all pentagons are not similar because we can easily draw slightly different or irregular pentagons. Okay, so not all pentagons are similar. Okay, so we're doing a bit of pie charts now. So Mr. Medhurst, he's been bragging in the staff room recently that he's got a new PS5. He won't stop going on about it. We get it. Move on. He said he plans to use the PS5 for 25 days in April, and he will not use it for the remaining days in the month. We need to draw a pie chart to show this information, okay? So first of all, let's think about how many degrees is this pie chart is going to represent one day, okay? So we know that there are 360 degrees in a pie chart, okay? And how many days are there in April? Well, 30 days has September, April, June, and November. So I know that there are 30 days in April. And that means that the 360 degrees, all the angles in this circle have to add up to 360, and that represents 30 days. So first of all, let's find out how many angles represents one day. Now to go from 30 to 1, I divided by 30. So to do the same to this, 360 divided by 30 equals 12 degrees. So I now know that 12 degrees is going to be roughly equal to 1 day, or 12 degrees will equal 1 day in this case, okay? So therefore, we're being told that he plays the PS5 for 25 days in April, okay? So if we work backwards now, so 25 days now, how do we get from 1 to 25 days? Well, we have to times it by 25, okay? And how many degrees is this going to represent? Well, we do the same to the 12 degrees. We're going to multiply this by 25, okay? And 12 times 25 is equal to 300 degrees, okay? So now we know that 300 degrees is going to represent 25 days, okay? Now I haven't got a protractor for this one, so you're going to have to excuse potential errors, okay? But I'm going to have a stab in the dark, and I think that maybe a bit lower. I think that is 300 degrees. Okay, so this remember what this represents. The 300 degrees represents the 25 days he plays PlayStation or plays PS5, and then this portion, which is 60 degrees, because that's all that's left over, is how much he doesn't play PS5. Okay, and in an exam, you could feel free to color. So you could do one in stripes, and you could do the others with dots. And all you'd have to do is make a little key telling the examiner that the lines is plays PS5 and the dots is doesn't play PS5. Okay. And then you've got a title as well. How often does Mr. M play PS5 in April? Okay, just a little bit of extra there, just underline that for the title. Boom, and that's all you need. Okay, but all the good maths is just for here. Okay, so that was question 3, pie charts. Question 4, number facts. So, is the following statement true or false? For any number, 35% of half of the number is same as 1/35 of 50% of the number. Okay. Well, let's test this out with 100. Okay. So we got 100. So we need to find so half of 100 is 50. So let's call this example 1. Let's call this example 2. Okay. So 1, and we're always going to be using 100. Okay. So 35% of 50 is equal to, and this is the same as doing 0.35 times 50. It's the same as doing finding 35% of a number. And that gives us times 50. That gives us 17.5. Okay, fair enough. Now, next we need to find 1/35th of 50% of the number. Okay, so we need to find 1/35th of 50. Okay, now there's no easy way to do this in a calculator, but we could literally just, in a calculator, you could type 1 divided by 35 times 50. Okay, and that will give you the same question up here. Okay, so do 1 divided by 35 times 50. Try again. 1 divided by 35 times 50. And that will give you 1.43. That's to 2 decimal places. And here we can definitively say this is, sorry, that's 50% of 100. Just so we know where we're getting all these numbers from. Half of 100. Easy peasy. So the answer is false. Okay, as we've just proven, if we did 100, if we find 30%, 35% of half of 100, it's 17.5. And if we find 1/35th of 50% of the number, it's 1.43. Okay, so we can clearly see that these values are different. 17.5 does not equal 1.43 to 2 decimal places. Okay, next topic. Okay, so the next topic now, we've got angles in triangles and lines. So we've got a little drawing here. We need to evaluate the angles A, B, and C. It basically just means solve. Okay, so we're going to solve for these angles. So we've got A, B, and C. Okay, so let's start with angle A here. So let's think about which rule we're going to use here first. Okay, so it looks like we've got a right angle triangle. So we know that angles in right angled triangles sum to 180 degrees. So all the angles in a right angle triangle add up to 180 degrees. What angles have we got? Well, we've got the angle 38 in the top corner. So 38, we've got this right angle here, plus 90, and we've got our angle A. These should equal 180. Collect 38 and 90. So 128 plus A, not just A, plus A equal to 180. Therefore, A is equal to 52 degrees. Okay. You do 180, take away 128, and you would get 52. Okay, or something plus 128 is 180, and that's 52. Okay. So next we've got part B. Now what have we got for B? We've got a straight line. Okay. So for B, angles on a line sum to 180 degrees again. So all angles on a line add up to 180 degrees again. So we've got 21, we've got 90, remember that right angle again, plus B equal to 180 again. So 111 plus B is equal to 180. Therefore, B has to equal 69 degrees. Job done. Okay. For angle C, I'm going to need to know B, which I've already worked out. So I'm going to write 69 degrees in there. I'm also going to need to know this angle here. Okay. So while I'm working this bit out, I know that angles on a line equal 180 degrees. So 114 plus unknown is 180. Therefore, the question mark has to equal 66 degrees, okay? So that's 66 degrees. So we've done A and B. Now let's do C under here. So now we've just got a normal triangle. But as we all know, angles in a triangle sum to 180 degrees again. So all angles in a triangle add up to 180 degrees. Doesn't matter what triangle it is. Okay. So what have we got? We've got 66, 69, and C. So let's do those. So 66 plus 69 plus C equals 180. 66 plus 69 is 135, plus C is 180. Therefore, C is equal to 45 degrees. Ta-da, and there we go. Okay, so the next topic now is basic algebra. Okay, so we're just going to got 3 questions to solve. Okay, so we need to solve 67 equals x over 432. Okay, so nice and easy. All we're going to do, we're going to try to get x on its own. Okay, that's all we ever try to do, is try to get x on its own. So what do we need to do to this equation, get x on its own? Well, currently we're doing x divided by 432. So what we want to do is times x, times this by 432, and that will cancel out both sides. But we can't just times the one side by 432, we have to times both sides by 432. So we're going to times both sides by 432, and that will give us 67 times 432 equals 432 times x over, and this basically works out like this, x over 432. These will cancel out, so then we're just left with solving the question. So 67 times 432 is 28,944, which is x. Ta-da! All done. Okay, so that's the first one. Next, we need to factorize 48x and 36. Okay, so first of all, let's list down the factors of 48 and the factors of 36. Okay, and remember, we're looking to take the biggest factor out of both of these. Okay, well, for 48 we got 1, we got 2, we got 3, we got 4, we haven't got 5, we've got 6, and we've got 8. Okay, those are all our factors there. For 36, we've got 1, we've got 2, we've got 3, we've got 4, we haven't got 5, we've got 6, and we've got 12. Oh, we've also got 12 for this one as well. Okay, so now, because I can see the biggest factor of both of these numbers is 12. Okay, so that is what I'm going to take out of 48x and out of 36. Okay, so I'm going to take out 12 here. Now, what's left in here? So let's think about this now. So in order to get factors of 48, what do I multiply 12 by to get 48? Well, I multiply it by 4. And if I want to think about 48x in particular, which is what we've got here, is I have to times it by 4x. Okay, so therefore the first thing in the bracket is going to be 4x. So if I re-expand this out, 12 times 4x is 48x. Next I got 36. Well, what do I multiply 12 by to get 36? Well, I multiply it by positive 3. Okay, so therefore the next number in the bracket is just 3. Okay, and then all you do there, just double check yourself, just re-expand it. So 12 times 4x, yep, that's 48x, and 12 times 3, yep, that's 36. Okay, job done. Happy with that? Tick, tick. Next one, we need to factorize q squared, take away 11q. Okay, so let's do this again now. Okay, so factors, do this a little neat this time. Factors of, so we've got q squared, and we've got minus 11q. Okay, well, what are the factors of q? We've got q, and that's it. That's only one of the factors of q. It's just q. And then for minus 11q, we've got minus 11, and we have got q. Okay. Now the common factor here is q. Okay, so we know that. What do I have to times q by to get q squared? So sorry, I know q is going to be outside my bracket. What do I multiply q by to get q squared? Well, I have to multiply by another q. So then I know the first thing in the bracket is going to be a q. What about this q here? What do I multiply q by to get minus 11q? Well, I have to multiply by minus 11. So therefore, the next thing in this bracket will be minus 11. Therefore, just recheck it, re-expand it. Q times q is q squared. Q times minus 11 is minus 11q. Happy with those, okay? So remember, factorizing is finding the highest factor and taking them outside the bracket, and then whatever left stays inside the bracket, okay? Let's have a look at the next topic. Nth term. So we need to find the first 3 terms in the sequence with the nth term 6n take away 10, okay? So we're going to have 2 boxes here. We're going to have nth term. So, we've got n is that, and the nth term is going to go below it. So the first 3 terms, we're going to have 1, we're going to have 2, we're going to have 3, okay? Put them in there. So if n is 1, we need to put that into 6n take away 10, okay? So when n is 1, we've got 6 times 1 take away 10, which is 6 take away 10, which equals minus 4. So the first term is minus 4. Next, we've got n equals 2. Again, we're using this 6n take away 10, okay? So 6 times 2 take away 10, which is 12 take away 10, which is equal to 2. The second term is 2. Done that. And then when n is equal to 3, 6 times 3 take away 10 is the same as 18 take away 10, which is equal to 8. So the third term is 8. Okay, and there you go. Those are your first 3 terms of the nth term 6n take away 10. Okay, easy peasy. Let's have a look at the next topic now. 2-event probability. So Nia's made up a game using 2 fair spinners. We've got a 3-sided spinner and we've got a 4-sided spinner here. She spins the triangular spinner and then spins the regular spinner. We need to list all the probable outcomes, and then we need to work out the probability that Nia's total score is a 2-digit number, okay? So I'm going to use a grid to help me out here, okay? So on the top, I'm going to have the tri-spinner results. And over here, I'm going to have the square spinner. Okay, very awkwardly written. So just here now, I'm going to write down the values of the square numbers here. So I got 2, 4, 6, and 8 over there. And then for the triangular spinner, I've got 1, 3, and 5. Okay, so now I'm not going to write out all the number combinations. I'm actually just going to skip a step and just add up the numbers, okay? Because that's what the game is. When you spin a spinner, and then you add up the scores of the numbers shown, okay? So for example, if you land on the square spinner, you get a number 2, and on the triangular spinner, you get a 1, you get a score of 3, and so on and so forth. So using this grid, you do 3 plus 2, you have 5 plus 2, here you do 4 plus 1, you do 4 plus 3, you do 4 plus 5, and so on and so forth. 6 plus 1, 6 plus 3, 6 plus 5, 8 plus 1, 8 plus 3, 8 plus 5, okay? So the next part now was work out the probability that Nia's total score is a 2-digit number. Well, how many of these scores are 2-digit numbers? We've got 1, we've got 2, we've got 3. So we know that 3 out of, how many are there? Well, just count these numbers. We use a different color pen. We need to count all the numbers in this blue box here. How many numbers are in that blue box? Well, we've got 3 times 4, so there's 12. So 3 out of 12 is how many different probabilities there are, okay? So 3 out of 12 is equal to 3 over 12. Simplify the fraction to 1 over 4. So we know there's a quarter chance or 0.25 chance of getting a double-digit score on the game. Okay? So let's have a look at the next question now, okay? So now we're on to question 9, unit conversions. So there's 2 questions here. First one says we need to complete the following. 1 mile is roughly equal to how many kilometers? Well, generally 1 mile we say is equal to 1.6 kilometers, okay? And the next part says, or how many miles is equal to something kilometers? So there's 2 blanks there. Now, generally, we always say that 2 is as a very broad generalization, we say that 2 miles is equal to 3 kilometers. But obviously, if we're looking at the top, we've said that 1 mile is 1.6. So it'd be more accurate to say that it is 2 miles is 3.2 kilometers. And all we've done is we have just doubled each of these numbers here. Okay, so we've still kept the proportions the same. All right. Then the next question now, how many centimeters squared is equal to 1 meter squared? Well, let's think about it this way. Let's think about how do we get a meter squared? Well, a square meter would be 1 meter times 1 meter. And that gives us 1 meter squared. Okay, that's as if we've got a square that's 1 meter by 1 meter. Okay, but we want the answer in centimeters squared. So first of all, let's change this. Let's change this length in meters to centimeters. And if we did that, we would have a square with one side of 100 centimeters and another side of 100 centimeters. That would mean that we have to do 100 centimeters times 100 centimeters. Okay. Now they're the same length. So obviously we all know 100 centimeters is equal to a meter. Then we just multiply these out. 100 times 100 would be equal to 10,000 centimeters squared. Okay. So therefore, 1 meter squared is equal to 10,000. Okay, so 2 zeros there and 2 zeros there. Make sure your answer has 4 zeros in it. Okay, so let's have a look at the next question now. Areas. So here we've got our triangle. We've got it looks like a trapezium, looks like a rectangle and a triangle. Depends how you want to think about it. Given that the triangle BCD, which is BCD, is right angled, so we're told that this is a right angle here, and that triangle ABDE, that is A, B, D, and E, is a rectangle area 36 centimeters squared. Okay, so we know the area of this is 36 centimeters squared. Find the total area of the shape above. Okay, well, here we go. We know that the length of A to B is 9 centimeters. We know the length E to D is E to C is 15 centimeters. But we know, because it's a rectangle, we know that the length E to D will also be 9 centimeters because it's the side of the rectangle opposite AB. So that's going to be 9 centimeters. And therefore, we should also be able to figure out the length of this side of the triangle, because 9 plus something equals 15. So this has to be 6 centimeters. Okay. Now we need to find this missing length here. We need to find the missing length DB. Okay. So let's just keep track of what we know. Let's keep this a bit tidier. Okay. Ta-da. So we know that's 6 centimeters. Now we need to figure out this bit here now. Okay. Well, we know that 9. Think about this now. So 9 times BD, which is this missing length here, is equal to 36. Okay, so 9 times something is 36. Okay, rearrange it. BD equals 36 divided by 9. Therefore, BD is equal to 4 centimeters. Okay, job done. Well, not quite near the end yet. So we know that the area of the rectangle is 36 centimeters. We need to find out this area of this triangle. Okay, so let's think about the formula. Area of a triangle, it is half times A times B. Okay, and what do we know? Well, let's take BD, which is 4 centimeters, which is the vertical line here. I've also got DC, which is 6 centimeters. Okay, let's call BD side A Let's call DC side B. Doesn't actually matter which one's which, okay? So we've got a half times 4 times 6. Tell you what, let's keep the units in, keep it tidy. Half times 4 centimeters times 6 centimeters. Well, you could either do a half times 4 first, that would be 2 centimeters. 2 centimeters times 6 centimeters is equal to 12 centimeters squared. Okay, so now we find the area of the triangle is 12 centimeters squared. What do we do now? Let's do a final bit up here. So total area is equal to rectangle plus triangle. And we know the rectangle is 36 centimeters squared. We know the triangle is 12 centimeters squared. Therefore, the total area of the shape is 48 centimeters squared. Okay, didn't mean to do that. That's the final answer there. 48 centimeters squared is the total area of the shape. Okay, so cool. That's it for the first part, and we'll see you in the next bit now. Okay, thank you guys. Bye now.